In this example, we are trying to create a function for volume. Let me read the problem. It says a box with an open top is to be constructed from a rectangular piece of cardboard. And that's what this rectangular piece of cardboard is. So, okay, the length of the rectangle is 25 inches and the width of the rectangle is 12 inches. So, with the dimensions of 12 inches by 25 inches. Now, by cutting out equal squares of side x at each corner and then folding up the sides. So, what that means is they are taking this big cardboard and taking like little squares, x by x squares, cutting it out, and then lifting up the sides. So, now the sides would be, for this side, this is going to be the side, which will be this side of my box, okay, and this width is going to be that side of my box. Okay, first let me start with this longer side. So I know the total length of the cardboard is 25 and I'm cutting x on this end and x on this end, so that's gone. So therefore this little length is going to be 25 minus 2x. So that tells me by this length is going to be 25 minus 2x. The same thing on the other side. If I am cutting an x here and an x here, this length is going to be 12 minus 2x, and that's going to be this length. Okay, now in order to do this problem, we need to know the volume of a box. So we know the formula for volume is equal to the length times the width times the height. Since you are folding up the squares of length x, this little length is going to be the height of the box. So the formula is going to be V is equal to, if I take the length, which is 25 minus 2x, multiply it to the width, which is 12 minus 2x, and multiply it to height x, this will give me the volume. And this is what the function is. Yes, the answer is 25 minus 2x parentheses 12 minus 2x parentheses x. Now, you may be asked to FOIL this out and write it. And if that's the case, then you would just FOIL it out, use algebra. So let me do here. The first thing I'm going to do is I'm going to take this x and I'm going to distribute it inside first, okay? So that is going to give me 25 minus 2x times 12x minus 4x squared. And then I'm going to distribute the parentheses, so 25 times 12x, right? So if you want to use your calculator, I'm going to do that right now just so that I don't put any arithmetical errors. 12 times 25 is 300. Okay, 300x minus 25 times 4. We should know this, right? 25 times 4 is what? 100. X squared minus 2 times 24 should be 2 times 12 should be 24, right? So 24x squared, and then plus 2 times 4 is 8x cubed. So if I combine the like terms and write it in descending power, I can write v of x equals 8x cubed minus 124x squared plus 300x. So this would be, you may be asked to write it in a simplified version in your WebAssign homework. Not sure. Check with the way that they want the answer. Here it doesn't specify anything. So sometimes the answer will be accepted like that, or sometimes you may have to write it like this using algebra. Okay. But whatever it is, we constructed the function. Now the next part of the question is asking us find, so this is where we are taking information from the function that we constructed, okay? Find the values for x, so which is this x value, technically the height of the box, right? The height of the box is what x is, for which the volume is greater than 250 inch cubed. So what it's saying is, so if 25 minus, I'm writing the, the version that I did not FOIL it times x is greater than 250. Okay, so that's what I need to solve to find what the x value would be. There might be a range of x values, but here I have a question. There are many ways of doing it. If I have to do it the algebraic way, I have to make sure I foiled this, the left-hand side, which I already did. Then I bring the 250 over, then it's a third-degree polynomial. I need to figure out how to solve it. Now, another way of doing this problem easier with the graphing calculator would be just to plug in the given function. So the function that you created, that's what goes in first. And if you see here, I'm not even putting in the foiled version. I'm just using the original one, just so that I don't have to worry about any arithmetical error that I created in the process. If I did, instead of minus, if I put plus or something like that, I don't have to worry about it here. So what I did was I put this function. Now, I'm going to put y2 as 250. And then what I'm going to look for is the point of intersection or the graph that is above this line 250. And why? Because it's asking where is it greater than. So I'm assuming when I graph this function, this function that I created, volume is going to be my dependent variable and x is going to be my dependent variable. And I may end up with the algebraic expression, like because it's a third-degree polynomial, I might end up with a graph. And I'm looking for the line 250. So I'm drawing the line y equals 250, right? And if there is a graph, I'm looking for the portion of the graph that is above this line. So this is the portion that I need. There is all these x values. So all these x values is what I'm looking for. That's above the line. Okay, so first let me graph the first function. Okay, I'll clear the second one. Let me first graph the function that I created and see what I'm going to get. Okay, so this is giving me a straight line, and I know that the graph of this equation is not going to be a straight line. So one other thing that might help me make a good window would be to looking at this function and creating the domain associated with it, which I should have done in the first place anyway. So one thing from here I can tell you, I can for sure say that for me to have a box, my 25 minus 2x must be greater than 0 for sure. And the other condition is also my 12 minus 2x should be greater than 0 or x should be greater than 0. So 12 minus 2x should be greater than 0 and also my x must be greater than 0. Now, if one of this does not satisfy, or at least if two of this, so height has to be 0, right? Should be greater than 0. So this is going to be a little algebraic work. So I'm going to eliminate that. And with this two information, if one of this doesn't satisfy, then I don't have a box. Okay. So x is greater than 0. So draw my number line, visualizing it. This is my 0. So I know it's 0 to the right. Now, there should be a point where I have a maximum value. So let me go 12 minus 2x is greater than 0. Solving this inequality is going to give me x is less than 6. So for me to have this box, the domain is going to be 0 to 6. So x max minimum should be 0, x maximum should be 6. So let me go to my window, make sure my x minimum is 0, x maximum is 6. Now, scale doesn't matter. Y minimum, I'll keep it 0 because I'm looking at a box and I don't want to worry about what is going to happen on my negative side. And then this one, I'm going to put a number, probably we'll start with 10. Why don't we start with 10 and see what happens? Okay, see, I hope you can see there's a blue graph here, but it's not very clearly visible. It's coming down. So it's starting here, coming down. So it's telling me there is a maximum point. So what I need is more of my y maximum. So randomly I'm just going to put a big number and then reduce if needed. I think that's good. Okay, so there is a place where the graph, so this is my 0, this is my 6, and that's where I am going to have a box, and this is where I have a maximum value. So now if I graph my y equals 250 line, I am looking at this and I know for the values which it is larger is going to be from this point of the x, right, from this point all the way from this point down this x value to all the way to this x value. So if I know these two coordinates, these two x coordinates, then I can put a bracket from this point to that point, I can say, or parentheses, because it just says greater than and it didn't say equal to. How do I find this? Go to second calc, use the intersect option here, and I'm looking for intersection on the left side, so move it closer to the point you want. And I'm still on the first curve, but I'm closer to the point I want. Hit enter. It'll automatically jump to the second curve. Yes, that's the second curve. Hit enter again. And when it comes to guess, enter again. And that is my leftmost point. So if I graph this clearly a little bit more better, I can say my volume is here and my graph is going to look like something like this. And that's my 250 line. And this point is x is equal to 1.128104. Now the next thing I need is this x value. So repeat the same process, go to second calc, intersect again. Now go to the rightmost point. Okay, and then enter, enter again, and that's going to be 4.209074. So here if I look at this, because it's saying round your answer to 3 decimal places, round your answer to 3 decimal places, I'm going to say the first number that I'm going to start with is 1 point. Again, it should be parentheses because it says just greater than. It didn't say greater than and equal to. So parentheses 1.128 comma and the 4.209. So this should be the answer for section B. Okay. Now for section C, it's asking find the biggest or the largest volume. So I know by looking at this graph, this is the place where I have a maximum. So I need to look for what this point is. So this is the maximum point, right? So with the same graph that I have, I can use second calc. I don't have to worry about the second line, so I can eliminate that if I don't want to see it. But you know what I need is the graph and the maximum point. So I'm going to go back to second calc and I'm going to hit maximum. Again, left bound, go to the left side of the point you think the maximum is, enter. Go to the right side of the point the maximum is, enter. Enter again. So it's going to give you the maximum point and the question is asking for the largest volume. Therefore, it is the y coordinate that's going to be the answer. And here again it says round to 3 decimal places. So the answer should be 350.143 inches cubed. So let me write the maximum point. I see is 2.557 comma 350.14279. Again, rounding off to 3 decimal places, I'll get that as an answer. Okay. Hope you all understood.